Dalton's law of partial pressure on the basis of kinetic theory. Consider a mixture of non-interacting gases in volume V. Let P1, P2, P3 with the pressures exerted by the individual gases and N1, N2 and N3 be their number of molecules in the mixture. If average V1 square, average V2 square, average V3 square dash are the mean square velocity of gas molecules of the respective gases, then P1 equals to 1 by 3 M1 N1 by V into average of V1 square, P2 equals to 1 by 3 M2 N2 by V into average of V2 square dash and so on, where M1, M2 and M3 are the mass of one molecule of respective gases. Now P1 plus P2 plus P3 plus dash equals to 1 by 3 M1 N1 by V into average of V1 square plus 1 by 3 M2 N2 by V average of V2 square plus 1 by 3 M3 N3 by V into average of V3 square plus dash equation 1. As the temperature of all the gases in the mixture is same, hence 1 by 2 M1 average of V1 square equals to 1 by 2 M2 average of V2 square equals to 3 by 2 kV into T. This implies M1 into average of V1 square equals to M2 into average of V2 square equals to dash equals to 3 kV into T. Question 2. Using 2 in 1, we get P1 plus P2 plus P3 plus dash equals 1 by 3 N1 by V into 3 kVT plus 1 by 3 N2 by V into 3 kVT plus 1 by 3 N3 by V into 3 kVT plus dash or equals to taking N1 1 by 3 V 3 kVT common under bracket N1 plus N2 plus N3 plus dash into kVT by V or equals to N into kVT by V, where N is the total number of molecules, equals to mu into Na into kV by T, kV into T by V or equals to mu RT by V, because Na into kV is R, equals to P, where P equals to mu RT by V is the pressure exerted by mixture of gases. Next, root mean square velocity of a gas molecules, VRMS. It is defined as the square root of the mean of the squares of velocities of molecules. Thus, VRMS equals to under root average of V square equals to under root 3P by rho. Hence, VRMS equals to under root 3P by rho equals to under root 3 VP by M under root 3 mu RT by M equals to under root 3 M by M naught into RT by M equals to under root 3 RT by M naught or M0, where M0 or M naught is molecular mass of the gas. Hence, VRMS under root 3 RT by M0 equals to under root 3 Na kVT into N by Na into M equals to under root 3 kVT N by M under root 3 kVT N by N into M, or VRMS equals to under root 3 kVT by M, where M is the mass of one molecule. Here we see that M by M naught equals to mu, where mu is the number of moles, M is the mass of given gas and M naught is the molecular mass, or we can write PV equal to mu RT, M by M naught equals to mu equals to N by Na. N is the total number of molecules and Na is the Avogadro number. From this relation we get M naught or M0 equal to NaM by N, where M is the mass of all molecule and M naught is the molecular mass and M is the mass of a molecule.